So hello everyone, we are back again with part 24 of the chapter Light, Reflections and Refraction. And in this video, we'll talk about power of lenses. Now, when we talk about power of lens, now what exactly is power? So some of you must be wearing spectacles and you must be knowing that your power is positive or negative. But do you think by just knowing positive or negative power, you can understand which lens are you wearing? So let's understand how to know whether the lens whether the spectacle lens which you're wearing is concave or convex. Let's begin. So what is power of lens? Power of lens is defined as the reciprocal of its focal length in meters. So the formula is basically 1 upon f. Power is 1 upon focal length. In some of the state board textbook, you will see its written power is 1 upon f, in bracket it's m. So student usually get confused with what exactly is this m. It's nothing but focal length in meter. It's trying to indicate that focal length is to be measured in meters. So what is power? Power is 1 upon focal length, and focal length has to be measured in meters. Till now, whatever we were solving numerical, we were solving everything in centimeter. But now when it comes to power, focal length has to be measured in meter. So if it is given in centimeter, we need to convert. Going ahead with what is the exact understanding of power. Since the power of lens is inversely proportional, we just saw the formula. Power was 1 upon focal length, which means it is inversely proportional, which means if focal length increases, what happened to power? It will decrease, and vice versa. If focal length decreases, power will increase. So from that, we understand that a lens of shorter focal length has more power, whereas a lens of long focal length has less power. The unit of power, which is power of lens, is diopter, usually represented with the symbol D. So if you see 2D written, it means the power of lens is 2 diopter. D is diopter. And what is 1 diopter? 1 diopter is a power of lens whose focal length is 1 meter, because formula is 1 upon f. The power of lens can be measured directly by using an instrument called as dioptermeter, which will help you in understanding what exactly is the power of lens. The power of convex lens. Now we know focal length of convex lens is positive. So if focal length is positive, power is going to be positive, because power is 1 upon focal length. So convex lens has positive power, whereas concave lens has negative power. So these were some of the statements. So usually it also happens that we don't use a single power lens. Sometimes we also use a combination, and sometimes we also need to get a lens which is a combination of concave as well as convex, so that we get the proper result. So if number of lenses are placed in contact, then the power of combination of lenses is equal to algebraic sum of power of individual lenses, which means if you have two lenses, whether concave, convex, you have to just add their power, and that will give you the resultant power. So just to give you example of the same on screen, combination of power, you can see we have a convex lens of power 4 diopter, plus indicate it's the convex lens, and concave lens of 10 diopter, negative, indicating that focal length is negative. Then if they are combined together, we get the combination of convex, concave, and that is going to be -6. And how did we get that? Because power equals to sum of individual powers, which is P1 plus P2. So if you see, P1 is +4 and P2 is -10, which means +4 -10 will give me -6 diopter. So the nature is going to be, the focal length of this is going to be combined will be negative over there, because the power comes out to be negative. So you can see a combination of convex lens of +4 diopter and concave lens of -4 diopter kept in contact gives you resulting power of -6 diopter. In general, whenever there are number of lenses contacted or connected together, the result is obtained by adding sum of their individual power. And if you have focal length of each of them, then you will not add the power. Then either you find the power of individual lenses, or if you want to add all of them, then it becomes 1 upon focal length. Total focal length equals to 1 upon individual focal lengths of all the setups. So that is to be kept in mind, that the focal length has to be in meter. So the lens system consisting of several lenses in contact are used in designing the optical instruments like cameras, microscopes, and telescopes. So if you remember, when we were discussing about uses of lenses, we use the term telescope for both convex as well as concave lenses, and cameras also. So you can see microscope, telescope, cameras, these are instruments which where we use the combination of lenses. And why do we use the combination of lenses is because it increases the sharpness of the image, and the image produced by using combination of lenses is also free from many defects which otherwise will occur using a single lens. So this was all about the power of lenses, and finally we are here with the last part of the video. uh, as in the next video is going to be our last video from the chapter light, reflection and refraction, and it's going to be numerical based on the spherical lenses. So if you have stayed with me for these 24 videos, stay with me again for the last video, which is going to be on numerical. That's it from my end. In the meantime, if you have any question, do put it in the comment box. Thank you and have a great time. Bye bye.